So we got a calculator question from 2019 here. Part A asks us how many fish enter the lake in this 5-hour time period, and we want a nearest whole number. And we're given a function that models the rate at which they enter, E of t. So if we're given a rate at which they enter and we want to know how many enter, that should just be an integral from 0 to 5 of E of t dt. And that came out to be 153.457,690, and so on. So we would say 153. Pretty easy there, I hope, for part A. 1 point for setting up the integral properly. And you don't have to write out 20 plus 15 sine pi t over 6. You can just write E of t. That's fine. Or if you want to write it out, that's also fine. And 1 point for the final answer of 153. Good or no? Any questions there on part A? Okay. Part B says, what is the average number of fish that leave the lake per hour over the 5-hour time period from 0 to 5? So the fish are leaving the lake. This is the rate at which they leave is L of t. We want the average number, so that's the mean value theorem for integrals. 1 over 5 minus 0 times the integral from 0 to 5 of L of t dt. And so you just set up your integral with your 1/5 out in front, and you get an answer of 6.059. And that was also 2 points, 1 for the integral setup and 1 for the final answer. Any questions there on A or B?
If you didn't put the dt, would you still get that point for setting it up or no?
If you didn't put the dt,
like I wrote out 4 plus blah, 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 but not the dt.
Probably, but don't forget the dt.
Okay.
It's important. I mean, it's a part of the integrand, so it needs to be there. They might show mercy on you. Depends on, they spend 3 or 4 days sitting there grading these tests. Depends on if they're grading your test on the first day. It depends on who you have, their mood, and if they're tired or if they're ready to be done and just want to give you the points, or if they're pissed off because they looked at a bunch of people that couldn't do the problems right for 3 days, and so try to write it. Yeah, it doesn't specifically say anything about the units, so we could say fish. We could say fish per hour. No, that's not fish per hour. That's just fish also. But if it doesn't specify units, you don't have to put units. All right, part C is where it starts to get a little bit trickier. We want to know at what time between 0 and 8 is the greatest number of fish in the lake. Well, there's 2 ways to look at this. The first way that I would, if I were doing this problem on my own, that I would probably do is I would say that the number of fish in the lake is represented by the integral of E minus the integral of L. And so I would just think about E minus L being the rate of change of the fish in the lake. E is the rate at which they enter, L is the rate at which they leave. So E minus L is just the overall rate of change. And so this, a rate of change of the fish in the lake, this is the derivative of some function. We'll call it, I don't know, we can call it whatever we want. Let's call it capital F of t equal to the fish in the lake, right? The derivative of this is the rate of change of the fish in the lake, and that's what E of t minus L of t itself is. And so the maximum, what did it ask for the maximum, right? The maximum number of fish in the lake will occur potentially at either the endpoints or at the derivative of a function that represents the fish in the lake. So f prime of t is E of t minus L of t. And to figure out when that's at a max, we set this equal to 0. And so you've got a graphing calculator. Your graphing calculator can tell you when the E of t minus the L of t function crosses to the x-axis, or effectively it can tell you when E of t equals L of t. And that happens, according to your graphing calculator, at a t value of 6.20356. And we could note by looking at the graph of E of t minus L of t, and in fact, I'll just put it up on Desmos real quick. What was the E of t function?
E of t was 20 plus 15 sine pi t over 6.
X though. X. Okay. And what was L of t?
4 plus 2 to the 0.1 t squared.
Okay. And so we can see from our graph here that that's the value we got. It crosses through at 6.204, they've rounded it to. And that when our t value is less than 6, our derivative, E of t minus L of t, is positive, and to the right, it's negative. So if we were making a sign chart with this value here, our derivative to the right is positive, tells us we're increasing. Derivative to the left is negative, tells us we're decreasing. And so that would tell us that we had a max when t was 6.20356. And it actually, does it ask for the actual greatest number of fish, or does it just say when, at what time? So we would say at 6.20356 hours after midnight. Everybody good there with that one?
Is that the pretty much only way to do it?
No, you could definitely do it another way. So it could also be done by, we could call, like we said, that function capital F, right? Capital F of t, we could call it the integral from 0 to whatever t value we're interested in of our E function minus our L function. And that would tell us, once again, that A prime, we could write it out this way and say that A prime is equal to E of t minus L of t, set that equal to 0. So we actually write out a function to represent F of t. And that would give us the same t value that we got at 6.0 whatever. And then the other thing you could do, you could just, basically that's the same up to this point, but you could just check each of these values, the endpoints and any of your critical values if you didn't feel like making the sign chart. And you could plug in the values. Like if you plug in 0 into this integral, 0 to 0 of E of x minus L of x, well, you get 0 fish. If you plug in 6.02, you get some number of fish. And if you plug in 8 into this integral, you're going to get some other number of fish. And that'll tell you. And in fact, they've got this in the scoring guide. So 135.01492 and at 8 they've got 80.919 something. So you'd see that at 6.02 is when the greatest number of fish were. Right? And this is just, we're integrating how many fish enter minus how many fish leave between 0 and t. Doesn't matter how many were in at the start, because whether we've gone 0 minutes or 6 hours or 8 hours, there were still the same number at the start. So there's 135 extra from the start at this time and 80 extra from the start at this time. So there's more in there at 6.02.
Okay,
that's the other thing you could do. I mean, this is the same basic setup, except we wrote out the integral and used that integral to find those values. But. All right, and real quickly here, last part
What
D.
was the scoring breakdown on that last one for C?
So 1 point here for setting A prime equal to 0 or E of t minus L of t equal to 0. 1 point for your answer and 1 point for the justification. So answer and justification. So whichever way you decide to do it. So be 1, 1, 1 this way, and this way be 1 point, 1 point, 1 point. Okay, part D, is the rate of change in the number of fish in the lake increasing or decreasing at 5 a.m.? So the rate of change in the number of fish, that's E of t minus L of t. We want to know if that is increasing or decreasing. So the rate of change, E of t minus L of t, how to figure out if that's increasing or decreasing? Well, you take the derivative. E prime of t minus L prime of t. And we are interested in that at t equals 5. And if you plug that into your calculator, plug those functions in and use the derivative calculator, you find that that equals negative 10.7 something, 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 which is less than 0. If the derivative is negative, then that rate of change is decreasing. And that one was 1 point for this and 1 point for the actual value. Not for the actual value, but for the fact that it's decreasing. Any questions there on part D?
Would it have worked if, because you took the derivative of E and L separately and then subtracted them, would it work if you did the derivative of the entire expression?
Yep, that would work too. Yeah, the same thing.